With today's session, we will discuss about TCP and UDP. This primary discussion we already conducted for TCP and UDP, that TCP uses a connection oriented, it's a connection oriented protocol, whereas UDP is a connection less protocol. It uses sequence number. UDP uses best effort delivery. TCP is a reliable one. UDP is unreliable. So how it is reliable, how it builds a connection, that we need to understand here. Okay. So if you take a UDP, it just push the data toward the destination. Okay. Whether this data is delivered or not delivered, that acknowledgement it's not going to receive. Whereas in TCP, before delivering data, we we form a connection with the help of three-way handshake. So this three-way handshake is SYN, SYNAC, and ACK messages. Okay. So I'll show you this with the help of Wireshark. Okay. So we'll access one HTTP website. I can't show you this on my base machine because if I use that, I'll lose my internet connection as well. So better I'll use the virtual machine for that. In this virtual machine, I already installed Wireshark. I copied Wireshark, but it's not installed yet. So let me show you how I can install it. It's a freeware, guys. If you just Google for Wireshark, you can get it. Meanwhile, I'll check the connectivity on the internet. Okay, so I'm connected on the internet on this virtual machine via Windows 8. Once this installation is done, we will see how this three-way handshake is done for any TCP based communication. So guys, any layer 7 protocol that uses TCP protocol on the layer 4 that we can utilize here, very simple one. You can answer in chat board if you know. I mean to say any program which is connection oriented and which use TCP as the transport layer protocol. If you know the answer, you can respond in chat box. Rahul, check at your end because the other fellows are not facing any issue related to voice. So I believe this problem is at your end. Okay, just cross check your speaker and all other things, internet connections. If guys, all of you are facing in this voice problem, just respond me on chat board. I'll try to resolve it. So this installation, I believe, is done. It's about to done. Okay, so it will take some time. Uh, yes, Mandy, we use UDP at certain places like When we have a real-time communication, that time we have to use UDP. And when we require a connection-oriented protocol, like I gave an example previously also, like suppose you want to purchase a small thing like chocolate or any small stuff, a pen, 2 rupees, like a five rupees pen or 10 rupees pen, a small pen. You don't take a acknowledgement or in the form of receipt for that. That's okay. But if you purchase any costlier stuff like laptop or mobile phone, okay, so definitely you will ask for a receipt acknowledgement for that. Okay, so in that case, similarly in computer networks also, just take an example like a real time streaming or video streaming or voice streaming. You don't require acknowledgement in that case. But if it is a normal delivery like HTTP protocol or a FTP protocol, in that case file has to be delivered properly from one end to another end. So that time we use connection oriented protocol like TCP. Yes, Rosh. Any online real-time scenario, chatbots or we can say live streaming like broadcasting, okay, video conferencing, we have to use UDP that time. Let me check my installation is done or not. It's taking more time. I guess we can run this program on base machine also. I cannot show you the DHCP part. DHCP also I want to demonstrate you on Wireshark, but that I can show you on. That's why I use this VMware. But meanwhile, we can check TCP connection on Wireshark. So Wireshark is installed on my base machine also. So let me open that. Guys, I asked you which protocol on layer 7 use a TCP protocol on layer 4, and meanwhile I responded with the answer also. So guys, uh, this is how the Wiresharks looks like. Okay, and it can capture any of the wireless LAN card or any of the LAN card, not wireless, any of the LAN card. So suppose I want to check all my network connections, so I can use a command ncpa.cpl to open a network connections. So guys, I'm using this connection now, wireless network connections. Okay, so all my traffic is going to and fro from this. Okay, so I can run a Wireshark analysis on that. Yes, this on transport layer, it may be using this UDP, but this on the upper layer it gets an acknowledgement, and on reliability is maintained on the upper layer. Means I mean to say the layer 7 itself. Okay, so here we see the multiple LAN cards I have, and right now I'm using this wireless network connections. So I'm just double clicking on this, okay, and it will start a capture in whatever traffic is going to and fro from this machine to the server is getting captured on this. Okay, but I'm not interested in all of the traffic. I'm interested in one particular traffic. Suppose I want to check the connections related to one blog. It's router ally.com. It's a really good documentation blog where CCNA guides and CCNP guides are uploaded. You can download it free. Okay, it's a good documentation website. So I access this website, but I want to see the TCP connections established between router LA and my computer. How I can check that? It's a ton of traffic going from my computer to the other computer. I just want to focus on the router LA only. How it could be possible? I can open up command prompt and I can find out the IP address of that particular website, www.routerla.com. You see, this is the public IP address of this website. So I just marked it, I highlight it, so it's copied now. Okay. Now I'll go to Wireshark and in the filter I'll put IP.addr equal that particular public address. So whatever traffic going to and fro from this particular computer is got captured now. You can see here SYN, SYNAC, ACK. These three initial communication is important. The SYN is from my computer 192.168.43.46 is the IP address of my laptop, whereas 173.205.126.127 is the IP address of this website www.routerla.com. So this is client, this is server, clear? And here we have SYN message. Okay, it's like if SYN SYNAC ACK is just like, suppose first time I'm meeting to someone, like, so I'll introduce myself, like my name is Samir, and I introduce what profession I'm doing, like that. Whatever information is shareable, I'll share. And in response, that guy will introduce himself, and that information will be collected by me. So I'll give an acknowledgement that I'm understanding. I'm under means, server is responding back. Here means like a, my friend is responding back with his information. Along with that, he's giving some gesture on his face, like he is smiling. So I understand. Okay, this guy is also understanding what I'm saying. It's like suppose I'm talking to some Chinese guy and he don't understand what I'm saying. So he will not give me an acknowledgement. We'll try to explain his information, but at that time I'll not be in position to give acknowledgement back as well. Similarly, when server and client, when they communicate with each other, if they are on the same terms, so first client will send a SYN message from client to server, and server will respond with SYN message from server to client, as well as server will give an acknowledgement message, and then client will give an acknowledgement message back to the server. Okay. Now we will try to elaborate this messages, what's there inside. So guys, see this source port number is there and destination port number is there. As this website is HTTPS, not HTTP, that's why the destination port number is 443, whereas source port number is 52,726. This port number is a random port number. Sometimes it is termed as ephemeral port number. Okay, and this is in sync with the session numbers. Okay, now try to elaborate this. What are the different parameters here? So I'll expand this. This is the first message coming from my client computer to the server's computer. Okay, and this is the details on transport layer, source port number, destination port number. Then we have sequence number and acknowledgement number. If you check here, okay, sequence number and acknowledgement number. First time when we send the data, we send it with the sequence number, and server responds with the acknowledgement number. And if you observe here, sequence number is 10, so the acknowledgement number is 11. If sequence number is 11, so the acknowledgement number is 12. We will try to observe this in this Vaisha capture as well. So see here, sequence number is 0 in this case, whereas acknowledgement number is also 0 in this case. Okay, because this is the first communication from the client to the server. If you go to the Wireshark again and check the response, that is SYNAC from the server to the client. If I double click here, see here, source port number 443 because server is responding back to the same port number 52,721. Okay, sequence number is 0 but the acknowledgement number is 1. What does it mean? The client has sent sequence number 0 and server has accepted it, and server is ready with next sequence number, that is sequence number 1. And then this client is sending an acknowledgement message back. If I open this, you will see here sequence number is 1 because previous communication from client to server was having a sequence number of 0. Now this is sequence number 1. Acknowledgement number 1. Why? Because the previous communication came from server to the server to the client as sequence number 0. That's why here we have acknowledgement number 1. If you observe here only, you can understand sequence number 0, sequence number 0, because this is first message from client to server, this is first message from server to client. Okay, but here we have acknowledgement number 1 because we already received sequence 0 and we are waiting for the sequence number 1. So the client responded back with sequence number 1 and acknowledgement number 1. What does it mean? That we have actually received sequence number 0 from the server to the client. Okay, okay, so this is how this three-way handshake completes. And where this information is stored, so this information is stored in the flags. See here, these flags are there. So yeah, different flags we have here. Amongst these flags, the most important one are the SYN and ACT flags. Okay, this SYN flag, if I open the first message, this is the first message from client to server. Here, if you observe, so SYN flag is set. If you observe the SYNAC message, here we have SYN bit set as well as ACT bit set. Okay, so the this 4 bits we have, this 3 dot and then 0. Here we have 2 dot 1 and then 0. So the total value is like 0 0 1 0. So it is 2. Whereas acknowledgement we have 1 0 0 0. If you look at the flag, it will be set as 0 1 2. Means the total size of this flag is 12 bits. This 2 represent 4 bit, this 1 represent 4 bit, this 0 represent 4 bits. Altogether 3 fours are 12 and 0x means this is a hex value. Okay, and one more objective of running this three-way handshake is to settle on the window size. Okay, we'll talk about window size first. Let me show you on this slide what this sequence number and acknowledgement number goes, how it goes. Sequence number 10, acknowledgement number 11, sequence number 11, acknowledgement number 12. And server and client are independent of each other. So here we have sequence number 5, so the acknowledgement number 6. If sequence number 6, then next acknowledgement number should come as 7. Okay, but if you keeps on sending every sequence number and get the acknowledgement for every sequence number, then that will be too much overhead. It's like a I'm delivering this training, okay, and I want a confirmation from you guys that you understood or not. So if I take a confirmation for each and every sentence or each and every word that you received or not received, you understood or you not understood, and you guys are keeps on responding with the acknowledgement, yes, no, yes, no. So that will be a too much overhead for me to conduct the session, right? So better what I'll do, I'll explain my topic in a one go, like I'm explaining the TCP. So I'll explain the whole TCP in a one go, and at the end I'll ask you guys, you understood it or not understood it. So that's like a my window size, okay? Means delivering the whole stuff and then getting acknowledgement back, okay? That's possible, and that's a doable thing, but taking acknowledgement on each and every word or each and every sentence, not possible. Similarly, in client to server communication or server to client communication, they they observe the window size. How they do it, let's take an example here, like sequence number 1, acknowledgement number 2. What does it mean? That I received the sequence number 1 correctly. Yeah, it is for first time only, okay? And then we will try to double the sequence numbers, like segment with the sequence number 2 and sequence number 3, and we got acknowledgement number 4. Okay, what does it mean? That 3 has been received correctly on the server end, and it is waiting for the pack segment with acknowledgement number 4. Okay, now it try to double the value 5, 4, 5, 6, 7. Okay, and at the server end we take that, okay, and we give acknowledgement. Actually here we should give acknowledgement number 8, but buffer got overflowed here now. 4, 5, 6, up to 6 it's okay. 7 is something overwhelming to the server, so server is not accepting that sequence 7, and it's again it's again uh, it's like a server want that sequence number 7 has to be sent resent. Okay, so that's why acknowledgement number 7. You can take an analogy here, like suppose this is a seller or uh, supplier, and this is like a consumer. So we sent one truck, that's okay, we received it, consumer received it, it's okay. Now supplier sent two trucks, 3 and 2, that is also okay. You sent fourth truck, now it's sent fourth, fifth, sixth and seventh. Now it's something overwhelming the godowns of the warehouses of the server. So now it got exhausted. So three trucks accepted, the fourth truck not accepted. It's saying send the fourth truck again. Okay. So the supplier will come to know that, okay, the capacity of the consumer is not more than three trucks. So we will settle on the three trucks only. Similarly, here we have segments, TCP segments, and whatever capacity of the consumer, whatever the capacity of the receiver is, that we have to follow. That window size at the both end is decided. Okay, let's take here. So this window size is decided here. 8 8192 8192 1460. Okay, so whatever max possible window size is accepted, that we will take forward, and that will be taken ahead. Okay, so server can accept, or the client can accept, server to client, that max value is 16,440 to 440 bytes. So that is the accepted window size, okay, from the client to server, whereas from server to client the maximum window size accepted is 1460. Okay, 1460. So whatever the capacity of the receiver is, accordingly the server has to send the data, otherwise it will be overwhelming to the receiver end. Okay, so that also decided within this our three-way handshake. It's like a I'm delivering the lecture. Suppose my speed is a normal speed, but suppose I'm a very fast speaker. If I speak very fastly, and some of the concepts you are grasping, some of the concept is going means you are not able to understand some of the concepts. Okay, so it's like a overflow flowing the buffer. Okay, so you are asking like slow down, you are asking to the trainer slow down, so I'm slowing down the sessions. So we need to adjust in an initial phase only. So within a 5 minutes, within a 4 minute, I understand, guys. If you are not able to understand, I need to slow down. Okay. Similarly, here also we have this three-way handshake is utilized to understand the capacity of sender to receiver and receiver to sender. I believe all of you are clear with this. Any doubts so far? Let me check my uh, client machine is ready or not. It's showing some issues. It's a virtualized environment. Furthermore, my laptop is getting overloaded with this virtual thing. It's eating my CPU cycles and the memory cycles. So I need to shut down, I believe, or this along with this Wireshark connection, it's putting lots of load. So I'll close this down. Okay, yeah, it's still not completed. Okay, I'll show you this. Once we're done with this, I'll show you how we can capture Wireshark capture for the DHCP captures also. Okay. Meanwhile, we will complete our discussion on the port numbers. So guys, we have some important port numbers like this, TCP port numbers and UDP port numbers. So these TCP port number, important TCP port numbers are 20, 21 for FTP. Normally we use it 21 for connection establishment and 20 for data transmission. We have 22 and 23 for SSH and Telnet. Uh, the role of Telnet and SSH is to have a remote access of the devices, remote access of the server. But there is one striking difference between SSH and Telnet. Anyone knows what is the striking difference between this? We'll talk about that offset types afterward. Okay. I want to keep the this discussion light, JK, because all of the things, if I delivered in one go, it will be difficult to grasp. SSH and Telnet. What's a major difference between SSH and Telnet? Both are used for same purpose. That's a remote access. We discussed this thing, I believe, in previous discussions, previous sessions as well. If anyone knows this, you can respond in a chat board. Okay. This SMTP and POP3, these both are used for mail, but when we send mail, that time we use SMTP. When we receive mail, that time we use POP3. Sometimes we have to use IMAP also for receiving mail. So if you are facing issues while sending mail, there may be issue with the SMTP. Okay. If you are facing issues with while receiving mail, maybe there is some blockage on the POP3 port number 110. Okay. Yes, in the for SSH we have encryption available. Telnet is a clear text. So security is the main reason we have to use SSH. Otherwise, Telnet can give us connection, but it is a clear text protocol. Can be a security breach can happen. Correct. So guys, like this we have SMTP POP3 for the mail. We have uh, TCP 53 and UDP 53 for DNS, but TCP 53 is used for DNS server only, whereas UDP 53 is used for DNS client. So whenever we use our communication, most of the time we use DNS client UDP 53 only. So this most of the time we are dealing with UDP 53 only. Guys, anyone know why we use this TCP 53? Where is the exact application of TCP 53? Anyone knows about this? We have HTTP and HTTPS for web services. HTTPS is a secured one, encrypted one, and HTTP is clear text. Okay. Yes, guys. And why we use DNS? So guys, when we have a primary DNS server and a secondary DNS server, and we want to transfer the important mapping of zone files, means like a host name and IP address mapping, okay, from one DNS server to one primary DNS server to secondary DNS server. So I don't want that file to be hacked, to be reaching to any means unwanted resources, like if any hacker wants to crack that file. So once that file is cracked, all the company's detail, like domain name and the related IP address will got exposed. So that should be transferred securely with encryption, and that's not provided on UDP. That is normally provided with TCP. Exact protocol name is DNSSEC, DNS security or DNSSEC. Okay, so that time we use DNS server for TCP 53. Okay. Guys, next we have this MAC address. So this MAC address is divided into two sections. One is OUI, the other one is vendor assigned. Okay. So an administrator is assigning IP address to the client computer. That time we use centralized. If DHCP is using centralized mechanism, so no IP address will get duplicated. Whereas if administrator is assigning static IP address, that time also administrator take care that no IP address will get duplicated. Okay. But how come MAC address will not get duplicated? How the MAC address is ensured that no two computers will get the same MAC address? There should be some central body to govern this, to control this, that no two computers will get same MAC addresses, same MAC addresses all over the world. Globally unique MAC addresses. How it could be possible? With the central control, and that central control is provided by IANA. I think I give shown you this website also. IANA.org. Here we have this IP address. So we have different regions here: Arin, Lacnic, Ripensisi, Afernic, Apenic. So we are falling in this range. As we are in India, we are falling in this APNIC range, Asia Pacific Network Information Center. Okay, Singapore, I believe, is the office for APNIC. Okay, uh, they control, actually INA is the main body and they have regional internet registry as APNIC, ARIN, LACNIC, AFERNIC. Okay. So if you want to manufacture any LAN card, you have to take a permission from, or you have to register your company with this INA, with the regional internet registry, and they will give you one organizational unique identifier. Suppose 0019D1 is assigned to my company. Okay, suppose I'm manufacturing a LAN card, just like a Intel or just like a Realtek. So first LAN card will have a MAC address 0019D1 as a start, then 000001, 02, 03, 04, 5, 6, 7, 8, 9. Then next will be A, 0A, 0B, 0C. Like this, it will keeps on, right? So that organization name is INA, and that controls this. Okay. So got this concept. So all the manufacturing companies of the LAN card, they should get this OUI. So you can have large number of LAN card within one OUI. Like a, how many characters we have here? 6 hex values, 24 bits. 2 raised to 24 means more than 16 million combinations are possible. Probably Intel may not have, it's like a, this one OUI may not be sufficient for them, so they may have multiple OUI. Okay, because they are manufacturing lakhs on lakhs of LAN cards. So for their servers, for their uh, circuitries, different network circuitries, even the companies like Juniper, Cisco also provides this special chipsets designed by the Intel. Okay, so lots of LAN cards are, or interface cards are manufactured by Intel. So they may not have one OUI sufficient for them. So they may have multiple OUI registered for Intel. I believe this point is also clear for you. Then guys, we have this unicast, multicast and broadcast communication. So suppose computer 1, this 172.16.1.11 wants to communicate with 172.16.1.12. So this is one-to-one communication. So it's called as unicast. Whereas if 172.16.1.11 has to send data to all of the computer, that time broadcast will be used. Okay. If suppose this computer wants to send data, 11 has to send data to 10 and 13 but not 12. So it's like a, all three computers are in the same group, 11, 10 and 13 are in the same group, but 12 is not part of that group. So when 11 send the data, it will reach to 10 and 13 but not to 12. That's a multicast. So guys, how switch recognize that this has to be sent to all the computer, this has to send to one particular computer? So again, there is the broadcast MAC address and there is a broadcast, this multicast MAC address as well. Is this, I guess, is stuck somewhere? Okay. CSMSCD will talk about in switching part. Yeah, we'll see that. Okay. So CSMSCD part we'll discuss in our basic switching part. Last part in our in our discussion is cabling. But before that, I'll show you the same communication of website that's using a that's using TCP and FTP, that is using also TCP communication on layer 4, DNS that's using UDP communication and on layer 4. Okay, so let's analyze this for only these particular protocol: ARP, DNS. Then we'll look at TCP, UDP, HTTP, and FTP. Okay, only these protocol we will look at. Okay, let me adjust the screen for here. Okay, so yesterday's topology, we have the IP address already assigned with the DHCP along with DNS. You can see here DNS server is also assigned. My DNS server is also up and running. Okay, web server is also up and running. So let's do a communication first for FTP dot, what address we have taken, I forgot actually. Let's check here on the services. On the DNS server I'm here, DNS. So ftp.pingster.in is the FTP site name, ftp.pingster.in. Okay, so the moment I done, I in given this command. See, actual packet is DNS packet. DNS packet means I want to get the IP address for ftp.pingster.n. Okay, but that IP will be provided by whom? DNS server. But DNS server's IP I have 192.168.1.3 is the IP address of DNS server. Okay, you can see UDP port number 53, destination port number 53, source port number is random port number, but layer 2 information is incomplete. Okay, because we don't know the MAC address of DNS server. So first of all we'll find out the MAC address of the DNS server. So this is ARP request going to all of the computers. All other computers are rejecting it. Then DNS server respond back with the ARP reply that contains the MAC address. Okay, now I can release the DNS query to the DNS server, which is asking for, if you go to details, it is asking for the questions ftp.pingster.in, and we don't have an answer for this. We want an answer from the DNS server. Okay, so this query will now be forwarded to DNS server. Okay, now DNS server will reply back. Let me open this, what's there inside. So if I go to outbound PDO, check here. So this answer for FTP is 192.168.1.5 for the name ftp.pingster.n. Okay, and if you check here on the UDP, source port number is 53, means DNS server is responding back. Server switch has their role, but as of now I'm not going in that details, except one thing I explained about switch, Mendi, that whenever we have a MAC address as a FFF 12 time F, that will be forwarded to all of the computers. Okay, but how the unicast communication is handled one to one, that details I have not shared yet, so that I'll discuss afterward. Okay, now I got a IP address. I got a IP address. Now we have TCP. We have, so TCP three-way handshake will be done, but this TCP packet is on hold. Why? Because we got the IP address 192.168.1.5 as the FTP server's IP address, but we don't know the MAC address of that. For that purpose, we will send a ARP request, and that ARP request will be broadcasted to all of the machines except FTP server. No one will reply back. FTP server replied back to the PC0. Okay, now we have a MAC address of FTP server who has the IP address 192.168.1.5. So now first TCP communication will initiate from here. You can see here outbound PDU. Okay, sequence number 0, acknowledgement number 0. Okay, it should have a SYN message actually. Let's check. It's not mentioned clearly here, but it is a SYN message. It's going to be delivered to FTP. FTP will reply back with SYNAC. Let me check. Yes, it has SYN ACK messages here. Okay, then it goes to PC0. Then PC0 will reply back with ACK message. You can see here, this is ACK message. Okay. Now, once we have this three-way handshake established, then actual FTP packet will start. This is a FTP packet. Okay. Source port number 21. Okay. Destination port number 1025. Now the data transmission will start. Now, so far we have established connection. Now actual data transmission will start. Okay, I'm removing it from simulation. I believe you got a idea, OV idea, how the connections has been established. Okay. Okay, guys. Now, last point in our discussion is cabling that we will complete. What about my VM? Yes, its installation is done almost. Okay, let it be. Keep it aside. Let's see. So, guys, when you look at the server room, you will see the cables, bunch of cables. So these cables, if you have not arranged it properly, cable management not done properly, suppose there is a problem in one particular computer, one particular server, so you may end up disturbing the other cables. Suppose we have floor 1, floor 2, floor 3 connected like this whole floor is one velcro bundle. Furthermore, one floor has multiple small rooms or labs. So these rooms are connected with one small bunch of velcro cables. Okay, and these cables furthermore tagged with or labeled with a white tag that PC1 room number 1, like this. So if anything goes wrong with this particular computer, so we will just focus on the LED lights or the physical status of the that particular port only, instead of disturbing the other cables. So this cable management is also one of the important thing that as a network engineer we should be careful about. Okay, and this PC and router, PC's backend, you can see here this port is not used today much. It's a coaxial port. Nowadays we don't use it, but this RJ45 connector is still used. Here we have different LED blinkings like green, amber, and we have routers. This is a small home router or small routers, small medium business router. where we have four LAN piece connections, cable connections, one input connections to the internet, okay, console connections to change the setting like this. Okay. We'll talk about the cabling in more depth with color codes. Before that, I'll talk in general what two major cables we use, two major categories of cable we use. One is UTP cable, unshielded twisted pair cable, Cat 5 or Cat 6. Okay, that's used for 100 Mbps of fast Ethernet connections or 1000 Mbps connections. Okay, whereas we have this fiber optic connections also. We have multi-mode fiber, we have single mode fiber. For longer distance, we use single mode fiber. For campus area network, we can use multi-mode fiber. Within a building, we can connect with a copper cable of this Cat 5. But suppose within a campus, and if two buildings are like 200 meters apart, so this will cross a maximum limit of 100 meter for Cat 5 cable or Cat 6 cable. So that's not going to serve our purpose. That time we have to use fiber optic cable. So we can use multi-mode fibers there. Okay, and single mode fiber is used for very long distance communication like city to city connected or ocean cables. Okay, it's very high precision, but at the same time it's costlier as well. This is a tool called as crimping tool used to make the cable for this RJ45 connector is used, and this eight strands are properly color coded, inserted into this RJ45 connector, and it get crimped with this. Okay, and this is handmade cable. Normally in production environment like data center or ISP, they don't use this handmade. Machine made patch cords are used, but in certain situation we may have to use handmade, or we should be aware what color codes are there. Okay, so let me explain this color code with the notepad. uh, Paint. So how many pins are there in our copper cables? So one has responded here. Yes. So we have 8 pins. Okay, and in a straight cables they are arranged like this. They're arranged like this. Okay, and they're connected with one-to-one cables connections. This pin number 1 to 1, pin number 4 to 4, 5 to 5, 7 to 7, and 8 to 8. Okay, and the pinouts are like this. Let me show you here. T plus, T minus, R plus, 1 2 3, and then directly 6 pin is used, R minus. Okay, and at the other end we are connecting it like this, R plus, R minus, T plus, and T minus. Okay, so connecting transmitter to receiver and receiver to a transmitter, so it is a smooth connections. Okay, color code exactly 4 5 and 7 8 we normally don't use it. It is used for some different purpose like P O E. Okay, if anyone knows the full form of POE they can put that in a chat board. And color code goes like this: white orange, orange, white, green. Then green is used on 6th. Okay, yes, check, you are correct. It should be power over ethernet. I think Jiggy also you want the same thing to convey, maybe typo mistake. So guys, white orange orange, white green green, these pairs are the important pair, rest of the pairs are not that important. Okay, but still we have to use that color code here as blue, white blue, and white brown and brown. Okay, same color code is used at the other end. So if you are connecting PC to switch, then we will follow this color code, and this color code is called as straight cable in short. Okay, so we normally only use these cable pins. These pins: pin number 1, pin number 2, pin number 1, pin number 2, pin number 3, okay, and pin number 6. These pins are not normally used, but we can utilize it for a special purpose, that is PoE. Clear with this? This is the color code for straight cable. Now let's take another scenario where we are connecting PC to PC or switch to switch. Okay, so that time scenario will be different. Here it will be same, like transmitter, receiver, and it's of no use to connect transmitter to transmitter and receiver to receiver. Correct. So if you are connecting PC to PC, it's of no use to connect like this. Then as Sheikh has suggested, we have to change it to cross cable. Okay, so how we can change this to cross cable? We have to make some changes here. Let me show you that. Just a second. We'll change this. Okay, and we'll change this as well. Okay, now what we will do here, this transmitter we will connect to receiver, and this transmitter minus we will connect to receiver minus. Okay, so the color code will also change. Color code will also change along with this. Okay, so here you can see this white orange is connecting here, so I'll write white orange here. So here we will have white orange, whereas this orange is be getting connected to 6, so orange is now here. Okay, and white green and green is on 3 and 6, that will connect like this. Okay, so white green and 6 has to be connected here. Okay, with green. Okay, so this is how the cross cable color code will be. Okay, so cross cable. Clear with this? Any doubt? Any doubts so far, guys? I believe all of the points are clear for you. If you have any issues to understanding this, so the like devices means PC to PC or router to router or switch to switch or switch to hub, we use cross cable. Whereas PC to switch or PC to hub or switch to router, we use straight cable. So most of the time we have to use straight cable. If we are connecting switch to switch or router to router, that time we use cross cable. Okay, and one more point on this, we use IO panels and patch panel, wall jack and patch panel to run the cable through the wall. So punching tool is used to punch this on wall jack and on patch panel. So if you want to change the position of switch or if you want to change the position of computer, instead of small patch cord we can replace it with long patch cord, but we don't have to pull the cable which is running through the wall jack, so we don't have to disturb the cable structure. Okay, so it will be a if we disturb the cable running through the wall, that may be a big problem. So that's why we have to use this structure like wall jack to patch panel fix, then we can change the position of the switches and change it with the patch cords. Okay, so guys, I'm done with the today's topic. Most of the points we have covered. Okay, now next session will be routing, basic routing. 11, so tomorrow is 12, 12, 4, 19. Guys, if you have any queries you can ask me now. Session 8. So tomorrow we'll start with basic routing. Okay, and along with that basic routing, we will take subnetting if possible. In basic routing, we have to take connected routes, practical, then static routes, default routes, and floating static route. And then host route, and after that subnetting. we may not cover this in one go. So whatever topics are there remaining, that we will cover up in the next session. Yes. Power over cross cable, rollover cable. Rollover cable, I'll explain you when we will uh, take a basic router concepts. Okay. In that, it's not that difficult to understand rollover cable. Rollover cable is altogether, it's like a pin number 1 here getting connected to pin number 8. But what is the use of that? That we'll understand when we connect our router to the PC for a console access. Okay. Any other doubts, guys, beside this? Uh, Too much depth of TCP header, I'm not going to cover up here. The required fields I covered up. The sequence numbers, the acknowledgement number, the flags, okay, and the window size. In more nitty-gritty details, this is not the sessions in CCNA. The more depth session I'm not going to cover up. That's on CCI actually, because that's overwhelming also, and that's going to cover up, consume more time as well. Okay, and I don't want to get burdened all of the uh, details here at the same moment. Okay, so I kept the sessions very light. We'll see if possible I'll share few of the points, and that should get relayed to some practical stuff, then it will make sense. Okay, any other guys points? Otherwise we are done with today's point. We'll stop here. Okay guys, good night then. See you tomorrow. Welcome.